Ever wondered how cryptocurrencies work, such as Bitcoin or Ethereum? What their underlying principles are? Or just in general, what if your bank does not exist tomorrow? Let's find out that and more in this video.
Login acceptance.
To understand blockchain, let's go back to 500 AD on the island of Yap, located on what is now Micronesia. Yapese people had stones like this everywhere. This is a Yapese coin. It was their money, it was about 200 kilogram. Spending this like modern coin would prove a bit of a problem. The Yapese solved this problem by not ever physically moving the coin. The coin is placed in a very visible location on their tiny island. Every Yapi knew the owner of each coin was, by memory. When two people wanted to transact, they would announce the change in ownership to the other Yapi, who would all update their knowledge of whom the coin belonged to. Thus the coin was exchanged. The Yapi were using what we call a distributed ledger. It's a ledger which each Yapi had a mental record of the ownership of all coins and thus would mentally update their ledger anytime there was a transaction. Its distribution is that ledger wasn't just known by one person, it was known by all.
So, in this video of blockchain, you're going to be learning about a small introduction about what is blockchain and how it works and what are the basic pillars behind the blockchains. So, you're ready to see what blockchain is? Most likely you have heard about blockchain by now. Blockchain is a breakthrough technology that is expected to author most industries in the coming years. Whether you work in financial wealth or healthcare or any other sectors, you will probably face the consequences by yourself soon enough. But what really is this thing you are going to face? You will be seeing further in this video. Wonder why it is called blockchain? A blockchain is a record of new transactions. When a block is completed, it is added to the chain. Say, a Bitcoin owner have their private passwords to an address on the chain through which their ownership is recorded. Cryptocurrency proponents like the distributed storage without a middleman. You don't need a bank to verify the transfer of money or to take a cut off transactions. And the next thing that we are going to learn is about three pillars of blockchain technology. Three pillars of blockchain technology which has helped gain widespread acclaim are as follows. The first one is decentralization, and the second one is transparency, and the third one is immutability. So the first one is decentralization. Before Bitcoin and BitTorrents came along, we were more concentrated on centralized services. The idea is very simple. You have a centralized entity which stores all data, and you have to interact solely with this entity to get whatever information you require. Another example of centralized system is bank. They store all our money, and when the only way you can pay someone is going through an interaction with the bank. So the traditional client server model prefers an example of this. So basically, the client server model looks like this, and you have a main server, and the clients are connected to the server. So what happens if you take the centralized entity away? In a decentralized system, the information is not stored by one single entity. So in fact, everyone internet can access information. In a decentralized network, if you want to interact with your friend, then you don't need a third party to interact with the friend. This was the main ideology behind Bitcoins. And you are in charge of your money, and you can send your money to anyone you want without having to go through a bank. So pillar 2 is transparency. It is one of the most interesting and the misunderstood concepts of the blockchain technology is transparency. Some people say that blockchain gives you privacy, while some say that the blockchain is transparent. Why do you think that happens? When a person's identity is hidden via cryptographic and represented only by the public address. So if you were to look up a person's transactions, you will not see that Bob has sent one BTC. Instead, you will see that ABCD123 has sent a BTC. So the third pillar is immutability. Immutability in the content of blockchain means that once something has been entered into the blockchain, it cannot be tampered with. Can you imagine how viable this is in the case of financial institute? Imagine how many embezzlements can be nipped in the bud if people know that they can work the books and riddle around the company accounts. The reasons why blockchain gets the property is that of cryptographic hash functions. In simple terms, hashing means taking an input string of any length and giving an output of fixed length. In the context of cryptocurrencies like Bitcoins, transactions are taken as an input and through a hashing algorithm which yields an fixed output of fixed length. So in the next part of this video, you're going to see how blockchain works and what are technologies included and so on. So that's it for the introductions. Thank you.
Modern technology allows people to communicate directly. Voice and video calls, emails, pictures and instant messages travel directly from A to B, maintaining trust between individuals no matter how far apart they are. When it comes to money, people have to trust a third party to be able to complete a transaction. Blockchain technology is challenging the status quo in a radical way. By using math and cryptography, blockchain provides an open, decentralized database of any transaction involving value, money, goods, property, work, or even votes, creating a record whose authenticity can be verified by the entire community. The future global economy will move towards one of distributed property and trust, where anyone with access to the internet can get involved in blockchain-based transactions, and third-party trust organizations may no longer be necessary. The uses of blockchain technology are endless. Some expect that in less than 10 years it will be used to collect taxes. It will make it easier for immigrants to send money back to countries where access to financial institutions is limited. Financial fraud will be significantly reduced, as every transaction will be recorded on a public and distributed ledger, which will be accessible by anyone who has an internet connection. Think of it as wills and contracts that execute themselves, or dated proof of existence for ideas, much like a patent. Blockchain will become a global, decentralized source of trust, but not everyone is ready to embrace it. A huge proportion of trust services, from banking to notaries, will face challenges on price, volume, and in some cases, their very survival. Public authorities could find it more and more difficult to enforce traditional financial regulations due to the new possibilities offered by the Bitcoin network to bypass traditional financial intermediaries. Unimagined new networks will evolve to meet society's needs more cheaply and potentially more securely. Will governments, financial and legal institutions embrace blockchain? What will happen to the ones who don't?
Now that you have a basic idea of what a blockchain actually is, let me explain how a blockchain actually works. To understand the working of a blockchain, you don't have to listen to long lectures or read huge textbooks. All you need to do is give me 5 minutes of your time and I shall explain how a blockchain works. How is security implemented in a blockchain? Or why do we say that the blockchain is a secure form of transaction? One of the major components of each block is the hash value of the previous block that is linked to it, as I've said before. So when a hacker changes the data associated with the block, the hash of this block has now been changed. So the next block that is supposed to connect to it can no longer identify this block, and our entire chain has now crumbled. Since our blockchain is no longer complete, this helps us to identify that there has been an external interference from a hacker or some other outside source. So now there are computers. So to make a change in our blockchain, we have to change not only the value of a particular block, but the value of all subsequent blocks that are linked to the chain. There are computers that can change the value of all these blocks in a matter of minutes. So the amount of time taken to change the hash value of a particular block is now set to 10 minutes, so that no computer or no person can change the value of all the blocks in the chain at a particular at random.
So what exactly is a blockchain? Blockchain is a distributed database that stores information in blocks, which you can think of as a kind of virtual container for data. As new data gets added, additional blocks are created. The blocks are then linked together chronologically to form a sequence of blocks called a chain. As new information gets added, the chains get longer. This method of data storage is called non-destructive, meaning old data never gets erased or overwritten because the previous blocks in the chain remain unchanged. Each new block that is written contains something called a cryptographic hash, a small mathematical fingerprint of the blocks that came before it in the chain, making it extremely difficult to tamper with the data that resides inside the blocks. One of the things that makes blockchain so powerful is its distributed nature. Distributed, in this case, means that data isn't just stored in one centralized database controlled by a single account or administrator, but across a wide-ranging network of computers called nodes. In fact, the capacity for global networking itself is at the very core of how blockchain works. Modern distributed computer networks began in the late 1960s with ARPANET, a precursor of the modern internet, which connected computers at research universities out west. But peer-to-peer networks, which power blockchain's communication and are so central to its functionality, are a much more recent invention. The first well-known peer-to-peer network was Napster, which arrived in the late 1990s. Napster, as you probably remember, allowed users to share music files between their personal computers. Each node, or independent computer on the network, has the ability to share data with all of the others without being coordinated by a central computer. To continue with the music metaphor, the peer-to-peer networks that power blockchain are like an orchestra without a conductor. Each node is a musician listening to a vast symphony and playing its own music by ear. Okay, so now we know that blockchains organize data in blocks. And we know that blockchains can use peer-to-peer networks to distribute and store data all over the world. But how does the blockchain know which nodes have accurate information? In other words, how does blockchain know what data is authentic if any node can modify the chain? What's to stop a malicious node from trying to fool the rest of the network for its own advantage? That's a problem called consensus, which is really about maintaining agreement on a network. Consensus, as it turns out, is a very old kind of challenge, which mathematicians and computer scientists call the Byzantine generals problem. What's an ancient general got to do with blockchain? Well, sending out messages between multiple parties and making sure they are valid is a problem that people have been struggling with for thousands of years. Imagine you want to send out a message to your army that says, "Attack at dawn," but your message is intercepted and replaced by your enemy with a counterfeit message that reads, "Retreat at dawn." If that happens, you've got a serious problem on your hands. On the battlefield and in finance, there are a lot of ways things can go wrong. But here's the headline. Blockchain claims to have solved the Byzantine generals problem using unique properties of high-speed computer networks and massive number crunching power. There are a number of different consensus mechanisms that blockchains can use to do this, but to give you an idea of how consensus works, here are some of the broad strokes. Participants on the blockchain use their computers to simultaneously solve very hard math problems. When one node successfully solves a math problem, a new problem is generated, and all the computers on the network switch from solving the old problem to solving the new problem. Solving hard math problems takes time, but because blockchain keeps full records of all the changes that have occurred and nothing is ever thrown away, the sequence of answers combined with the times the answers were sent out to all the other nodes on the network allows the entire network to validate that the data hasn't been tampered with. We've simplified this view of blockchain. There's a lot of wonky math going on behind the scenes. But if you followed along so far, you've probably got a pretty good idea of the general way blockchain creates trust in a distributed network with no single party in charge.
Hope all of you got a basic idea on how blockchain works. Now, let us now see the application and benefits of this technology. The blockchain gives the internet users the ability to create and value digital information. What new business applications will result from this? And the number one is smart contract. Distributed ledgers enable the coding of simple contracts and will execute when specific conditions are met. Ethereum is an open source blockchain project that was built specifically to realize this possibility. The number two is the sharing economy. With the companies like Uber and Airbnb flourishing, the sharing economy is already a proven success. Currently, however, users who are to hail a trade service have to rely on an intermediary like Uber. And number third is crowdfunding. Crowdfunding initiatives like Kickstarter and GoFundMe are doing advanced work for the emerging peer-to-peer economy. The popularity of these sites suggests people want to have a direct say in product development. And the number four is governance. By making results fully transparent and publicly accessible, distributed database technology could bring full transparency to elections or any other kind of poll taking. Ethereum-based smart contracts help to automate the process. And the number five is chain auditing. Consumers increasingly want to know that ethical claims companies make about the products are real. Distributed ledgers provide an easy way to certify that the backstories of the things we buy are genuine. The number six is file storage. Decentralizing the file storage on the internet brings clear benefits. Distributing data through the network protects files from getting hacked or lost. And number seven is prediction markets. The crowdsourcing of the predictions on event probability is proven to have a high degree of accuracy. Averaging opinion cancels out the unexamined biases of disturbed judgments. The number 8 is protection of intellectual property. As is well known, digital information can be infinitely produced and distributed widely along the internet. This has given web users globally a goldmine of free content. However, corporate holders have been not so lucky, losing control over the intellectual property and suffering financially as a consequence. And the number 9 is IoT, Internet of Things. What is IoT? The network control management of certain types of electronic devices. For instance, the monitoring of air temperature in a storage facility, smart contracts make the automation of the remote systems make management possible. The result of the system increases the efficiency and improves cost monitoring. The number 10 is neighborhood microgrids. The blockchain technology enables the buying and selling of the renewable energy generated by the neighborhood microgrids. When solar panels make excessive energy, Ethereum-based smart contracts automatically redistribute it. The number 11 is identity management. There is a definite need for better identity management on the web. The ability to verify your identity is the linchpin of the financial transactions that happen online. And the number 12 is AML and KYC. AML, anti-money laundering, and KYC, know your customer. Practices have a long potential for being adapted to the blockchain. Currently, financial institutions must perform a labor-intensive multi-step process, and at the same time, increase monitoring and analysis the effectiveness. Number 13 is data management. Today, in exchange of the personal data, the people can be social media platform like Facebook for free. In future, users will have the ability to manage and sell their data on the online activity generates. And the number 14 is land title registration. As the publicly accessible ledgers, blockchain can make all the kind of record keeping more efficient. Property titles like a case in the point. They tend to be susceptible for fraud as well as costly and labor-intensive manner. Number 15 is stock trading. The potential for R efficiency in the share settlement makes a strong use for case for blockchains in stock trading. When executed peer-to-peer, trade confirmation becomes the most instantaneous. Potentially, this means the intermediaries. So these are the uses. Now let me walk through the benefits of this technology. And the number one is first benefit is greater transparency. Transaction histories are becoming more and more transparent through the use of blockchain technology. To change a single transaction record, that would require the alteration of all subsequent records and the collision of this entire record. Thus, data on the blockchain is more accurate, consistent, and transparent when it is used to push through the paper-heavy process. The number second is enhanced security. There are several ways to blockchain is more secure than the other record-keeping systems. This along with the fact that the information is stored across the network of computers instead of a single server. It makes very difficult to hackers to compromise the transaction of data. The blockchain has the opportunity to really change how the critical information is shared by helping to prevent fraud and unauthorized activity. Number 3 is improved traceability. If a company deals with the products that are traded through the complex supply chain, you can imagine how hard it to be trace them back to its origin. When the exchanges of goods are recorded to a blockchain, you end up with an audit trail that shows that the asset come from every stop makes it on the journey. And number 4 is increased efficiency and speed. When you use traditional paper process trading anything in the consuming process prone to human error and often requires a third-party mediation. By streamlining and automating this process with the blockchain, transactions can be completed faster and more efficiently. Since record keeping is performed as in a digital ledger and multiple ledgers, you end up with a less clutter. The number 5 is reduce cost. For most businesses, reducing cost is a priority. With blockchain, you don't need many third parties or middlemen to make guarantee because it doesn't matter if you can trust on your trading partner. Instead, you have to just trust on the data on the blockchain. Surely, even such a beautiful must be facing some issues, right? So, some people in the blockchain industry have pointed out that the blockchain has some overhyped when in reality, the technology has limitations and inappropriate for the many digital interactions when the likes I will mention. The number one is complexity. The blockchain technology involves an entirely new vocabulary and the network size. The blockchains are not much resistant to bad actors such as the anti-fragile. That is, they respond to attacks and grow stronger. And the transaction cost and network speed. Bitcoin currently has a notable transaction cost after being touted as a near free for the first few years of its existence. And then human error. If the blockchain uses as a database, the information going to the database need to be high quality. So events need to be recorded accurately in the first place. Unavoidable security flow. One of the notable security flow of the Bitcoin and blockchain is that other half of the computer working as a node service network tell a lie. The lie will become the truth, and this is called 51% attack, and this was highlighted by the launch of Bitcoin. And politics, because of the blockchain protocols offer an opportunity to digitalize the governance models because miners are essentially forming on the other hype. The forking of the blockchain process that involves updating of the blockchain protocol, and when the majority of blockchain users are agreed to it. We all now understand how Bitcoin is a huge implications of blockchain technology. So in the upcoming part, you will have a broader view of the Bitcoins. Thank you.
As we saw in the previous sections, now we can see how Bitcoins are a huge part of finance and blockchain. Let's see Bitcoin, cryptocurrency, blockchain. So what does it all mean? Let's start with some quick definitions. Blockchain is a technology that enables the existence of cryptocurrency. Bitcoin is the name of the best-known cryptocurrency for which blockchain technology was invented. A cryptocurrency is a medium of exchange such as a dollar or rupees, but is digital and uses encryption techniques to control the creation of monetary units and to verify the transfer of funds. Before going into Bitcoins, let me introduce you to cryptocurrency. Cryptocurrency can be seen as a tool or resource on blockchain network. Anything dealing with the buying, selling, investing, trading, micro-tipping or other monetary aspects deals with the blockchain native token or sub-token. Cryptocurrency is a digital currency formed on the basis of cryptography. Although all are cryptocurrencies, the tokens can serve different purposes on this network. Moving on to Bitcoins. The domain name bitcoin.org was registered in 18th August 2008. Satoshi Nakamoto implemented the Bitcoin software as open source code and released it in January 2009, and his identity remains unknown. What are the basics of a new user? As a new user, one can get started with Bitcoin without the understanding of its technical detail. Once you have installed a Bitcoin wallet on your computer or mobile phone, it will generate your first Bitcoin address, and you can generate furthermore whenever you need one. You can disclose your addresses to your friends so that they can pay or vice versa. In fact, this is pretty similar to how email works, except that Bitcoin addresses should be used only once. Now you may ask, what are the parts of Bitcoin transactions? First is balances. The blockchain is a shared public ledger on which the entire Bitcoin network relies. All confirmed transactions are included in blockchain. It allows Bitcoin wallets to calculate their spendable balance so that new transactions can be verified, thereby ensuring they are actually verified by the spender. The integrity and chronological order of blockchain are enforced with cryptography. Next is transactions and private keys. A transaction is a transfer of value between Bitcoin wallets that gets included in the blockchain. Bitcoin wallet keeps a secret piece of data called private key or a seed. Finally, processing or mining. Mining is a distributed consensus system that is used to confirm pending transactions. It enforces a chronological order in the blockchain, protects the neutrality of the network, and allows different computers to agree on the state of the system. The current value of 1 Bitcoin in INR is 5.5 lakhs. So, the properties of such a transaction, you may ask. Well, it is irreversible, pseudonymous, fast and global, secure and permissionless. So, in short, the best thing about Bitcoin is that it is decentralized. Bitcoin is free from government interference and manipulation. It's small wonder that users call Bitcoin Money 2.0.
Hope this video was informative, and if you want more videos, you know who to call.